Alright, ladies and gentlemen, I am going to walk you through how to fill in the blank spots on 4 two-column proofs, and I'm going to be using the 4 two-column proofs that are on the back of your homework worksheet. So 19, 20, 21, and 22. So to start with, number 19 says, in the diagram, measure of angle 1 plus the measure of angle 2 equals 132 degrees, and the measure of angle 2 equals 105 degrees. So down here they're saying that the entire measure of this angle is 132, because if I add these together I get that, and the measure of angle 2, this angle, is 105 degrees. And then from there to there would be 132. And they're saying, if that's true, complete the argument to show that the measure of angle 1 equals 27 degrees. They're saying because the whole thing's 132 and angle 2 is 105, angle 1 has to be 27 degrees. And this is something that could be intuitive, but remember, we're not trying to figure out obvious things. We're trying to support the argument that obvious things are true. So in this proof, the first thing they've done is they have taken the 2 given statements up here and listed them first. And then they get this statement. Now, where did this come from? And so sometimes when you're trying to figure out where it came from, look at the steps above. So I see the measure of angle 2 equals 105, and I see measure of angle 1 plus measure of angle 2 equals 132. So it looks to me like what they did was they took the first statement and they rewrote it, except when they got to measure of angle 2, they replaced it with 105, which is what measure of angle 2 equals. So anytime they replace something, that's called substitution, property of equality. So what would go here is substitution. Alright. That's supposed to be a U. Okay. Now, the next thing is, all of a sudden they have measure of angle 1 equals 27. And where did that 27 come from? So if I go back to the last step, what I see is that if I subtract 105 from both sides, I would be left with this statement, measure of angle 1 equals 27. And since I'm subtracting the same thing from both sides, that is the subtraction property of equality. Okay, so moving on to number 20. It says, in the diagram, segment AB is congruent to segment FG. So segment AB is congruent to segment FG. And line BF bisects segment AC and segment DG. So line BF bisects segment AC and segment DG. So they're saying that this line here is bisecting those two segments. Well, what does bisect mean? Well, if you think back to what we've already learned, you should know that a bisector divides a figure into 2 congruent parts. So if BF, line BF, is bisecting this segment, that means that AB, segment AB, is the same length as segment BC. So I could add a congruence mark. Well, since this one has 1 tick mark, I'm going to give this one 1 tick mark. And then the same thing holds true for segment DG. DF would be congruent to FG. So I'm going to do 1 tick mark on DF. So just looking at this figure, I already know, based on what they told me, that all 4 of these smaller segments are congruent. How do I show that with symbols and improved form? So over here, they've written out the statements and the reasons. We just have to fill in the blanks. So segment BC is congruent to AB. BC is congruent to AB. Well, I knew that. I already marked it. BC congruent to AB. I marked that because it told me that BF, line BF, bisected it. So my reason that I knew that is the definition of a bisector, because that's what a bisector does. Next thing says segment AB is congruent to segment FG. AB is congruent to FG. Well, I already marked those congruent. AB is congruent to FG. Why did I mark those congruent? Well, if I go back to what I already read, I see that same statement up here. So since that's part of the given information, my reason for writing it here would be given. Okay, next part. FG, segment FG is congruent to segment DF. So segment FG is congruent to segment DF. That sounds a lot like and looks a lot like what I already established over here with, because BF is a bisector, then FG has to be congruent to DF by definition of bisector. And then the last thing says blank property of congruence. Well, we only learned 3 properties of congruence. We have reflexive, symmetric, and transitive. Well, reflexive, if you think back to yesterday, is we're saying that something's congruent to itself. Well, that's not what's being said here. We're not saying segment BC is congruent to segment BC, so I know it can't be reflexive. Symmetric means I flip the order of the congruent statement. So if I look here, FG, there's no FG down here. So it can't be symmetric because I didn't flip the order of the previous statement. So by default, it has to be transitive. And the reason it's transitive is because they're linking BC, see, BC's here, BC's here, to DF through a series of congruent statements. So AB, AB, FG, FG. So they're saying because BC, segment BC, is congruent to the same things that DF is congruent to, they have to be congruent to each other, and that is transitive. So that was number 19 and 20 from your homework. Now when you got to 21, it got to be a little bit more involved. So on 21, what they did was they gave you all the statements and all the reasons, but jumbled them all up together. And we need to pull them back apart and organize them. So statements, and over here we'll have reasons. And just understanding the setup of a 2-column proof will help you with this, because one thing that I told you guys yesterday was statements, the only thing I can put over here are mathematical statements. So all of these statements over here with equal signs, they're going to go on the left-hand side. And in reasons, in that column, the only thing I can put over there is definitions, postulates, theorems, properties. So all of these that involve postulates and properties, they're all going in the right-hand side. So already I have an idea of what has to go where, even if I don't know the right order. And then also, given, well, I know what that means. That means that that's going to go with the given information. So if I look up here, it says PQ equals RS. Well, that's the given information. So given has to go with PQ equals RS. So I'm already off to a good start without even having read the entire problem. Okay, so now I can mark those out. And the other thing is, I know that the very last thing that goes in a 2-column proof is what I'm trying to prove. Well, it says in the diagram below, PQ equals RS, copy the diagram and arrange the statements and reasons in order to make a logical argument to show that PR equals QS. This is what I'm trying to prove. Therefore, it has to go last. So PR equals QS. Go up here, mark that out. So already I've narrowed down just based on understanding how 2-column proofs work. Let's go to the figure. It says PQ equals RS. So they have these tick marks. And I'm trying to prove that PR, so from P to R, I'm trying to show that PR is equal to QS. So even though I don't know exactly how to do that, I still can use what I know already to narrow things down. So I'm going to look at what I have left and see if I can make some connections. When I look at what's left, what I notice is that this one, segment addition postulate, is in here twice. Segment addition postulate. So first of all, I haven't heard of that postulate yet in class, but I can deduce that I'm adding segments. And when I look at all these statements, I know PQ represents a segment, QR represents a segment, so I know this is adding segments. Now, all three of them are adding segments. The question is, what's the addition postulate part? Well, since both of these reasons are the same, then the statements have to look similar. And what I notice is this one and this one looks pretty similar. So I'm thinking, even though I don't fully understand this concept, I'm thinking that they go together. And this could be a trial and error exercise. But let's just put those together. And I'm going to leave some space because I may have to go in between and add things in the right order. So I'm going to move down a little bit, and I'm going to put PQ plus QR equals PR. And my reason is segment addition postulate. And then I'm going to mark those out. So PQ plus QR equals PR, and then segment addition postulate. And then I'm going to go over here and I'm going to write RS plus QR equals QS. And it's the same reason, segment addition postulate. Okay, so mark those out. Now let's see. Let's look at what this is saying. PQ plus QR, PQ plus QR equals PR equals PR. Well, that makes sense. If I add the length of PQ to the length of QR, it's going to equal the length of P to R. So I'm thinking that's probably the segment addition postulate because it makes sense. I'm adding those two segments together to equal the whole thing. So I feel pretty confident about that. I'm going to move on. The next thing says, what's left? Addition property of equality. Well, I know what that is. I know that means I'm adding the same thing to both sides of the equal sign. And when I look at what's left, I have this statement here. And when I look further, I see that QR and QR, well, the same thing is being added to both sides of the equal sign. So these two have to go together because that is the addition property of equality. Now the question is, where do I put it in my proof? Well, look at what we started with. We started with PQ equals RS. And that is right here. So I'm thinking this statement needs to go below that. So PQ plus QR equals RS plus QR. And my reason? Addition property of equality. All right. So that narrows it down to one last thing. Substitution property of equality, and before I write it, I'm going to check if it makes sense. So PR equals QS. PR, if I go up here, here's PR, and then PQ plus QR is right here. So it is substitution because I took this out and put PR in its place down here. And then QS, well, QS is equal to RS plus QR, and that's up here. So basically, in this proof, they're taking this statement and they're replacing the left and the right hand side with what they equal. That's substitution property of equality. So, substitution property of equality. So, the bottom line of this exercise is, just because I may not be able to create a proof all on my own without any help, I know enough about the proofs in order to make educated guesses as to how to organize them. And we will work towards creating our very own from the ground up, but For now, we just need to understand ones that are already organized. And so this is an exercise in understanding that process. We're going to wait on 22 for another video. So if you need to review this stuff, go back and watch the video. Otherwise, go ahead and move on to the next proof.